Planning has three parts. The other one we looked at was changeover cost. Okay, so we looked at changeover cost or setup cost. Okay, then in this class, let's look at sequencing rules. Okay, so we'll be looking at sequencing rules and criteria used to evaluate sequencing rules. Okay. Then the other part of this topic is Johnson's rule and the Gantt chart. Okay, so this is what goes on. So let us look at in this class. Let's see, look at if we can combine the sequencing rules and criteria used to evaluate sequencing rules. Also, we'll be able to look at Johnson's rule and the Gantt chart. So we can now look at the sequencing rules. Okay, so there are four sequencing rules. Okay, there are four sequencing uh, sequencing rules. The first one is called FCFS, which is called first come or first come, first served. Okay, then the other sequencing rule is SPT, which is called the shortest processing time. Then we have the earliest due date, earliest due date, and CR. So earliest EDD, CR is called the critical ratio. All right, so this is what we have. Okay, so these are the four sequencing rules. Now, there are three criteria used. There are three criteria used to evaluate each sequencing rule. Okay, so to evaluate each sequencing rule, there are three criteria. The first criteria is average flow time. Okay, average flow time. Okay, so flow time or completion time. So average flow time or completion time. Then we have, okay, now this flow time is the cumulative frequency. Cumulative frequency of processing time. Then the second component, second criteria, okay, so to evaluate each sequencing rule, be it first come, first serve, shortest processing time, earliest due date, or critical ratio. These three, they apply to each of them. So average flow time or completion time, then average job lateness, okay, so the smaller the lateness, the better. So the smaller lateness, the better. Then the smaller completion time, the better also. Smaller flow time, the better. Okay, so this is what we have. Then we have the other one. Okay, so the other one is actually the average number of jobs in the system. Average number of jobs in the system. Okay, so the few jobs in the system, the better. The few jobs in the system to work on means better efficiency. So if you have a number of tasks that you have given you, number of jobs that you have given someone, then if that person is able to work on those jobs very fast and clear them, then that would be better to measure the efficiency. Right. So that's what goes on. So we are simply saying sequencing rules are five: first come, first served, shortest processing time, earliest due date, critical ratio. Now, to evaluate each sequencing rule, we have three criteria. That's average flow time or completion time. Okay? So the smaller the flow time, the better. If you're able to work on a job fast, and finish working, the better. So flow time is just the cumulative frequency of processing time. So average job lateness, the smaller lateness, the better. Okay, if you are late by a smaller margin, the better. Than if you take a vehicle to the garage, then somebody is late by a day, is better than somebody being late for more than a day. Okay, from the time you are taking the vehicle to the garage. Then the average number of jobs in the system. If there are very few customers in the queue, then they'll be able to measure your efficiency to say you are doing a good job. So if you have very few vehicles to work on, you can give me other jobs to do because you're able to measure my efficiency. I'm able to clear the backlog or service vehicles in the shortest possible time. The few jobs in the system to work on means better efficiency. All right, so this is what we have. Okay, then we have the other one. Okay, so now we can look at this question here. The workshop manager, okay, so the workshop manager, this one, I'm sure you're able to see this, if you're able to see it. The workshop manager at Toyota Zambia, okay, service center must decide the sequence in which the four vehicles in the workshop must be serviced. He has developed these estimates based on the first come, first served. So with the exam, they'll give you the first come, first served. Then other sequencing rules come from the first come, first served. So they'll give you, so the other sequencing rules come from, so you take note, other sequencing rules come from first come, first served. Okay, sequence. So if you can see here, we are talking about the workshop manager. A total Zambia must decide the sequence in which the four vehicles in the workshop must be serviced. He has developed these estimates based on the first come, first served. Okay, so you have vehicle ID number. You have 226, 229, 224, 225. Then we have processing time. We have 27, 33, 41, 29. Then the due date. So this is also called processing time. Processing time. This one is due date. So the first vehicle that came for a service was 22 plate number 226. We have the other one, which is the 229. Okay, we have 224 to 225. So rank the first come, first serve, shortest processing time, critical ratio sequencing rules on the three criterias: the average flow time, average number of jobs in the system, and average job lateness. So as we come here, we have okay, so we have what we call first come, first served is what was given. So you have the vehicle ID, then you can go for processing time, due date, then you go for flow time and job lateness. Okay, so this is what we have. Okay, so what is going on here is that we, in every organization, we use the first come, first serve, but it may not be a good sequencing because somebody could have come early for a service, but here's a complication. We find that whatever whoever is supposed to attend to that person is a medical doctor who hasn't yet come at work there, at the office, at the clinic. Then the other people can just be waiting, even just want to us find out, okay, what time they should get their medicine, just like that. So you find that even in an exam, you have question one. Question one is very tough, but it came first. It's question one. So can you start with it? You can say, even if it's a first question, you don't have to start with it. So you check the question that is very easy to start with, which will take you a shortest processing time. That's why we have these other sequencing rules like shortest processing time. So start with the question with the vehicle that could have it's just a shortest processing time. Okay, maybe you just want to fix the tires. Okay, now other works you find that you want to do a body work, it can take more time. So that's why we are going for other sequencing rules. So we have this data is from the question here. Okay, so this is like from this question. I'm just getting the data as it is. So you have the due date here is 39, 30. So we are evaluating this table, 60, and 75. So this is the first conference table. So flow time, like I mentioned, flow time is a cumulative frequency of processing time. Flow time is the cumulative frequency of processing time. That's our float time. So meaning at here it will be 27 plus 33 is 60, 101 and 130. So we are adding, okay, it's just a matter of we brought the 27 here, 27 plus 83 is 60, 60 plus this one is that one. All right, so this is how we're getting the float time, cumulative frequency of processing time. So job lateness now. How do we get our job lateness? If you pass the due date, you are late. So job lateness means that if we pass the due date, then we are late. So should we pass the due date, we are late. So here we are not late because the due date is 39. So here we are not late. Here we are late by, you compare these two. To get the job lateness, you compare these two columns. If you do pass the due date, then you are late. So here we are not late. We are late by 30. We are late by 41. Then here we are late by how many days? If people are following, we are late by how many? 55. Is that clear so far? Okay. So I'm sure you are with me. So let's evaluate this table. Evaluating the table. We are still evaluating this table. So average flow time. What's average flow time? So let's check here. 27 plus 60 plus 101 plus 130. So this is 318, the total. The total of the processing time is 130. The total of the lateness, 30 plus 41 plus 55, 126. So average flow time, 318 divided by 4. 29.5. Average job lateness is 126 divided by 4. So 126 divided by 4 gives us what? 31.5. Then average number of jobs in the system is equal to total flow time over total processing time. So total flow time is 318 over 130. The 318 here over total processing time 130. So meaning the answer is 2.45. 2.45. So that is the first come first served table. So let us go to the other one. It was saying rank the jobs, rank the first come first served. So we are done. Let's go to the shortest processing time. So shortest processing time, what is going to happen here is that the SPT table okay, coming from first come, first served table. So here we are going to have what we call vehicle ID, then your processing time, load time. So before that one, first we have a due date. We have the due date. Then you have the flow time, job readiness. So this is what goes on. Okay. So this is what goes on. So this one is coming from here. So which job should be done first? The job that has the shortest processing time. So 227. So the first with the 226. It has the shortest processing time of 27 coming from this first come first served table. So it has 27. So it will be 226. Yeah, the job first job is to be 226. Okay. So it will be 226. So it's 27 and what? 27 and 39. Then you go for the other job here is 225. 225 as 29 and 75. 29 and 75. Then we have which other one? 229, 33 and 30. 33 and 30. We are ranking them starting with the first one, the first one with the shortest processing time. All right, then the other one is 224, 41 and 60. 224, 41 and 60. So our flow time would be 27, 27 plus 29, 56, 56 plus 33, 89, 89 plus 41, 130. So here we are not late. Even here we are not late. Here we are late by 59. We are comparing these two. Flow time minus due date. Okay, so job lateness is simply flow time minus due date. If we pass the due date, we are late. If you pass the due date, then you are late. So here we didn't pass the due date, we are not late. So this one will be 70. Okay, so 59 plus 70 is 129. So 27 plus 56 plus 89 plus 130, 302 and 130. These are the totals. So evaluating the table, okay, average flow time. Okay, that's average flow time, 302 divided by 4. So 302 divided by 4 is 25.5. Average job lateness. Average job lateness is 129 divided by 4, 32.25. Average number of jobs in the system is equal to total flow time over total processing time. So 302 divided by 130 is 2.32. So now this is the table for the shortest processing time. So let's now go for critical ratio. So critical ratio coming from first come, first served table. So our critical ratio is equal to due date over processing time. So this is for ranking. Are we together? Are people with me? So for 226, let's check here. For 226, our critical ratio is what? So for 226 coming from that, this is the mother here, first come first step. So 226 due date is 39 divided by 27. 229 is 30 divided by 33. 224, it is 60 divided by 41. 225, it is 75 divided by 29. Okay, so the ratio here will be, okay, so 226 would be 39 divided by 27. Then we have 229 is a 30 divided by 33. Then 224 is equal to 60 divided by 41. 225, 75 divided by 29. So the first one will give us what? 39 divided by 27, 1.44. 30 divided by 33, 0.909. 60 divided by 41, 1.46. 75 divided by 29, 2.59. So the first job to do will be the job with the shortest ratio. Start with the job with smallest ratio. So this one will be number 1. This one will be number 2, number 3, and number 4. So we are going to have vehicle ID. So the vehicle ID there. Then we go for processing time. Due date. Flow time. And job readiness. Are people following so far? Are you okay so far? Or there are people behind? All right. So this is what we have. Okay, so the first vehicle to do to start with 229. So 229. So 229, you pick float time and lateness and job and due date. Then the other one is 226. So 226, okay, 27 and 39. Then what else? 224. 224 is 41 and 60. 225, okay, is 29 and 75. So what is our flow time? 33 plus 27 is 60, 101 and 130. The total here is 130. The flow time, 33 plus 60 plus 101 plus 130, 324. Then for the first one, we are led by 3. 60 minus 39, we are led by 21, we are led by 41. 130 minus 75, okay, we are led by 55. 3 plus 21 plus 41 plus 55, 120. Evaluating the table, average flow time is actually equal to 324 divided by 4, 81. Average job lateness, 120 divided by 4, 8. Average number of jobs in the system, total flow time over total processing time. So it's 324 over 130. Average number of jobs, okay, so 324 divided by 130 is 2.49. Then what happens? We do a summary table. Okay, for recommendation, then we go for sequencing rule. Okay, so under sequencing rule, we have 3 sequencing rules that now. First come, first served, shortest processing time, critical ratio. Okay, so average flow time, and then you rank, then average job lateness, we rank, then average number of jobs in the system, we rank. So for the first come, first served, what do we have? First come, first served, we had what? Average, average flow time, average flow time was actually 75.5. Average job lateness was 32.25. Average number of jobs in the system, average number of jobs 2.32. So here, this is what we have. So for this one, average flow time 75.5. Average job lateness 32.25. Average number of jobs 2.32. Furthest processing time. So furthest processing time is this one. Okay. All right. So let's go back a bit. First, we go for first come first served. Our first come first served was what? First come first served. Let's go back here. Our first come first served table is this one. 79.5. First come first served was 79.5. 31.5 for the redness, and the other one is 2.45. Okay, so click on the same link. Are we together? Click on the same link so that we can wrap up this question. Are people with me? Hello? Click on the same link so that we can wrap up the question. Is that okay? Have people gotten my point?